Here we're going to talk about adding or subtracting rational expressions where they already have common denominators. That makes our life a little easier, and if we think back to a different fraction example, maybe just with some whole numbers, if we had, say, 5 nines take away 3 nines, we're only subtracting the numerators because the bottom tells us what size the pieces are. So this is 5 1/9 size pieces, take away 3 1/9 size pieces. So even when we don't know the number, I still know after I add and subtract these, they'll still be 2b sized pieces. But one thing I notice on this that doesn't make a huge difference, but in terms of writing can be really confusing sometimes, is the negatives are out front of these. I usually like to pick to put it on the top or bottom. It can kind of just blend in with the fraction bar and it's hard to see that it's even there. So one thing we can do is remind ourselves, well, if this entire fraction is negative, this entire fraction is negative, just distribute those negatives on the top right now before I forget about it. So negative b and negative 1 times negative 5y makes it plus. And putting this negative so it's not lost here in the middle by the fraction bar on both of these. So negative 8b and negative 9y. So now we can think of it as combining them. And so we just want to combine like terms. I have negative b plus negative 8b gives me negative 9b. And positive 5y and negative 9 gives me negative 4y. So only adding or subtracting the numerators because those tell me how many, the bottom tells me the size. So I end up with negative 9b minus 4y all over 2b. And there's nothing I can factor out of the top. 9 and 4 don't have any common factors, so there's no way I can cancel that with the bottom because it would have to come out of both terms. So that's as simple as I can get that one.